And just for the record, every day that I'm in here and I go over stuff with the class, I'm recording it and posting it. So if, like Friday, my fourth period didn't ask anything, so I didn't record anything. This class did ask stuff, so I recorded it and posted it for Friday. So I want to talk about just going through like what you think it's going to look like and the format and everything. So just showing you the way that it looks. Now, obviously, this is a PDF version of it, but this one has it set it up with, it tells you right here where the formulas are. It's kind of weird that it says formulas, then questions, then tables. We've had people get confused before and get like, you're not supposed to turn the page, but they're in there. Make sure you know where they are before you get started. If not, stop somebody, make them tell you before you get started. So there's the formulas the way it is on our orange sheet. On our orange sheet, we have it as a front and a back, which means I put that page and this page like side by side instead of on two separate pages, but it's the same thing. And then it goes straight into the questions. Now it's going to tell you this thing. So like, let's just look at how much of a page it takes up. So like that one takes up like a half page. This one does not take up very much. Does not take up very much. This one takes up a big chunk of it, about half. And this one does not give you very much space. So like just kind of getting an idea of how much space you'll have on them when we're going through these problems. So this is what it says first is it says, this is section 2, which is the free response section. But it says questions 1 through 5 spend about 65 minutes on this part of the exam, but that is not timed separately. You have 90 minutes to do 1 through 6. It is suggesting that you spend 65 minutes on this one, which means it suggests 25 minutes for number 6. I think that's a little much. But all of the free response section is one timed section. So my suggestion of how to go through these, and everybody's going to be different, and this is just my suggestion, not like you have to do this, is scan through these really quick. Pick the 2 or 3 that you are most comfortable with. Go straight into those 2. Skip and go to 6 and spend a little bit of time on 6. And then come back to the ones, because 6 counts so much, I want you to not run out of time during 6. I don't want you to run out of time on a problem that you're like, I know this problem, I feel good about it. So I want you to get those done first. Spend time to think about 6. If you have to rush yourself on a problem that you don't feel as good about. I didn't used to say it this way, but I think this is the best way of my suggestion. Now, some people are just going to work front to back, and I can't sit there and tell you what to do. I don't care. But that's my suggestion of how I would do it. So let's just go through this first thinking, okay, I'm scanning through. I want to see what I want to do. So this problem, I can look at this really quick, and just looking at these 3 words, I know that this is dealing with least squared regression line stuff. So I know it's something of that, which y'all read this one, so y'all know what it's about. Looking at this one, what kind of problem does it ask me to do here? And I know I'm just showing you right now. Confidence interval. I can look at that really quick and say, it's asking me to do a confidence interval. And I also want to know what kind of confidence interval. So what kind of confidence interval is it? So I can look at that very briefly and see the gist of this one is going to be, and do you think it'll be a 4-step or not? If it just asks you to do a construct a confidence interval, yes. So here's 4-step confidence interval proportion. What are some words here that are going to pop out at me? I see a lot of stuff dealing with probability. So this is a probability problem. I'm going to skip ahead. I'm just going to zoom in on this part right here. What is this one talking about? See, tell me one word. Why did I just circle that word? What should that word mean to you? I'm looking at 3 graphs, and it tells me to describe them. Socks. It's actually a compare problem, but it says describe how they are similar and how they are different. I might feel good about that, but that one might be one that I'm like, that might take up a lot of time if I start there and get so comfortable in writing that I'm going to spend all my time writing. This one, what kind of problem is this? because of this, that is a test. And then I go into number 6. So we really, really quickly went through, and you should expect what we just found. 1 confidence interval, 1 test, 1 on probability, and 1 on something else. Sometimes they're like mixed in together, but that's a pretty good guess that you're going to have 1 test, 1 confidence interval, 1 on just probability, and then 1 on something. So at that point, that should give you a direction of where to go as far as where I want to start. Now, probability can be like anything. So you would probably want to look at this a little bit more. And this one's actually kind of a mix of a bunch of different things. But that gives you an idea of, I feel good about these. I want to start here. So I would probably think, in my opinion, I would maybe start here because a confidence interval for a proportion seems pretty easy. And I can knock it out pretty quick and basically give myself other time for other problems. This one, you just saw this one. It shouldn't take that long. It's kind of a picky one though. I might then go to probability. This one I might even save for last, only because I can then see how much time I need to allot for it. Not that I don't feel comfortable with this problem. It's, do I have time to write more or do I not? That's the kind of problem I would want to condense. Just kind of giving y'all some perspective of how I would approach these type of problems. So now let's actually look through them. I'm not going to like answer the problems, but we can talk about them enough. I'm not going to answer all of them. Sullivan and I were very surprised when we saw this problem because we've never seen a problem asked this way. If I ask you about a least squared regression line, and I ask you, do you know what it means to be positive, strong, and linear? I would imagine you probably say yes. Most of you feel pretty good about that. Now, if I say put it into words of what that one word means, that's a kind of a funny way to say it. And so we were kind of, it's such an easy problem, but it's such a hard thing to explain too. What does it mean to be positive? As one increases, the other increases. They both increase, or they have a direct relationship. As one increases, the other one increases. That one I feel pretty good about. What about linear? If I ask you, do you know what it means to be linear? You would probably say yes, but it's a hard one to put into words.
You could say the change is constant.
The rate of change is constant. That was one of their acceptable things. The amount as x increases by 1, y increases by a constant amount. Their acceptable solutions were kind of picky versus their not acceptable solutions, which I thought was weird. So for linear, they said some of their acceptable solutions were the points generally follow a straight line, which I thought was not a very good explanation. The relationship between x and y is straight. I didn't think that was a very good explanation. And length and weight have a constant slope. I thought that was kind of vague. The points all line up, which sounds like the points generally follow a straight line pattern they would not give you credit for. You could draw a straight line through the points. They would not give you credit for. Basically, the big difference between these is I'm looking at these like a preschooler and I can do this versus here I understand that it is a relationship between the two. And I think that's what they wanted to see. But we kind of thought those were weird questions for an easy type of question. Strong, I thought was another one. I think this is your best answer. Strong would be what we predicted was close to what actually happened. I think that is your best bet for what strong would be in this problem. But I always explain it as how close the points are together. And they said they wouldn't accept that, but they would expect deviations from the least squared regression line are small. So they were kind of picky with this problem. I thought this was really weird that they said they accepted the correlation coefficient close to 1, but they did not accept there's a high positive correlation. I guess here was showing that you understood that high meant close to 1. I I think this was a very weird problem, just that section of it. So back to this one now. B and C, I hope you feel good about. Interpret the meaning of slope in least square regression line in context. So this is our interpret. I'll be circling that word. It is slope. What is the value of our slope in this problem? Did I not put it up there? Oh, yeah, right here. So as our what?
X.
And so it is defined as our length increases by 1, we predict our weight in kilograms to increase by about 35.02 kilograms. And then C, one wolf in the pack has a length of 1.4 meters. With a length of 1.4 meters, had a residual of this. What is my equation for residual? Is this my observed, predicted, or neither? Neither, because that is my what? That is my X value. So I have to take my X and plug it in. Did anybody do that? Which number is that? My observed or my predicted? 32 point what?
938.
And my residual was negative 9.67. So I'm just taking negative 9.67 and adding 32.538 to it to get my observed. Not always, but typically question number 1 is something like this where it's a short problem. It's just asking either concept or something like easy probability, and it doesn't take that long. For a typical number 1, I thought part A was tricky with what they were wanting out of it. All right, so number 2, I'm not going to go through the whole problem of doing this one. What is our equation for a one sample proportion interval? What does it start with? I can fill in my numbers there. And again, as I'm reading, I should be doing things like this all the way through. When I plug in my numbers here for A, I would end up getting this. So now B says the manager estimates that each customer who asks for a water cup but fills it with a soft drink costs the restaurant 25 cents. This is talking about people who do that. Suppose that in the month of June, 3,000 customers asked for a water cup when placing an order. Use confidence interval constructed in part A to give an interval estimate for the cost to the restaurant for the month of June for the customers who asked for a water cup but filled the cup with soft drink. What do I do with this number right here? What numbers does it give me in part B?
2,000.
Which is my what? And then it gives me this number, which will tell me how much each one of them costs. This is a proportion, but I want to split it into how many people first. So how do I figure out how many people? Multiply it by 3,000, and I get like 564.961, and that's how many. And what would I do with that? Multiply that by 25 cents to get, what would I do over here? the same thing, and you end up getting like, so this one isn't like a specific to a certain type of problem we use, it's just converting. Questions on that problem? It's transforming data. Really, you can do 3,000 times 0.25 and multiply it to it, but I think it makes more sense to start. All right, number 3. This one says grocery store purchases. Oh, this one actually we want to do. Purchases melons from 2 distributors, J and K. Distributor J provides melons from organic farms. The distribution of the diameter of melons from distributor J is approximately normal with mean of 133, standard deviation of 5. What is a very important word there?
Normal.
Approximately normal, which means I can use the curve, I can use the green sheet, I can use Z, I can use anything that deals with that. So, how do I find the probability for part A? And so I'm not doing all my work here, I'm really shorthanding this. I'm finding the probability that X is greater than 137. So I'm going to convert it. So what number do I plug in?
37.
Divided by. And then I can end up finding that probability, Z, all that stuff. All right, distributor K provides melons from non-organic farms. This is the probability the melons selected at random from this distributor will have a diameter greater than 137. So I've got, here is my probability for distributor J being greater than 137. Here is my probability for distribution K being greater than 137. And it tells me 70% come from distributor J and 30% come from distributor K. Just based off of what I said, what would you draw? I know what the probability is if it's from distributor J. I know what the probability is if it's from distributor K. I know that 70% come from J and 30% come from K. How can I visually show that? I would go tree diagram. So, JK, what would be here? And then here I'm looking at greater than 137 or not. This one, it gave it to us. This one, whatever I get as that answer would be what goes here. So for a melon selected at random from the grocery store, what is the probability the melon will have a diameter greater than 137? What would I do? Okay, so let me come up with color here. How do I get this number? Multiply 0.3 times 0.8413. So I'm just going to go with, these are my multiply down numbers. How do I get the answer to part A, or part B? Yeah, follow me there? Those are the two paths that get what I want. What is a word in C that is extremely important? What else? Yes, what else? To tell me what type of problem I'm doing. So that means I'm doing a conditional. So what is the given part? So does that go first or second? So that's this answer would go here. What is the probability that the melon will be from distributor J? So this answer is going to be red plus orange as your denominator. What's going to be in your numerator? already given that it's here. I'm given that it's one of these two. So now it's just, I'm going through these super quick without doing numbers. If you're just following pieces of me, like given, that's the kind of stuff I want right now. I can go through these if I need to later though. I'm not going to go through all the pieces of this one. B is pretty neat. You use min and max and stuff, but that's kind of irrelevant right now. This one gives us, what do I call this? What is this called? What kind of chart? How many variables? Two. Two-way table, I've got two variables. I'm doing a test. What kind of test is this? I'm checking something about two different variables. So it is, what general category is it? The whole chapter is on this. Chi-squared. So I have to decide if it's, which one is it definitely not? Which chi-squared is it not? It's not goodness of fit because it's not just one variable with different categories. I have to decide if it's homogeneity or independence. What's the one thing that tells me that? How did I sample? Is this one or two? One population, two variables, which makes it Alright, now I want to go into number 6. I think this is probably, the problem itself is not hard. This is one of the harder number 6 I've seen. And I had one of my smartest students come in and say, I didn't write a single thing down for number 6, and that is terrible. And I yelled at him when he told me. Because, and this is the part that I want you to get out of today, you should be able to do something in number 6. That doesn't mean you have to be able to do all of number 6. But if it counts as 25% of your grade and you can do part of it, that helps. So I'm going to read this to you. It's going to sound super confusing, but then I'm going to talk about what I would want you to do if you're just like totally lost. Consider experiment in which 2 men and 2 women will be randomly assigned to either a treatment group or a control group in such a way that each group has 2 people. The people are identified as man 1, man 2, woman 1, woman 2. Possible 6 arrangements are shown. 2 possible methods of assignment are being considered: a sequential coin flip method, which I'm going to describe in a second, or a chip method, which is described later. For each method, the order of assignment will be man 1, man 2, woman 1, woman 2. A says, for the sequential coin flip method, a fair coin is flipped until one has 2 people. An outcome of tails assigns the person to the treatment group. An outcome of heads assigns the person to the control group. As soon as one group has 2 people, the remaining people are automatically assigned to the other group. Now fill out the chart with the probabilities. And some of you are just going to go, what? And just sit there. And that's, I totally get that. And I honestly expect most people to do that here. Part 2 of Part A says, for the sequential coin flip method, what is the probability that man 1 and man 2 are assigned in the same group? That is a very easy problem if you have done Part 1. So I've got, thought I put it all on one slide. Here are different arrangements. The actual important part of this problem is way up here, where this is the order. But let's say I am totally lost. I don't know where to start. but I think I can do part A. I mean, part 2. What should I put in these if I'm lost? Like, what's a good guess? Okay. Am I going to get any credit for part 1 if that's wrong? No, that's fine. For the sequential coin flip method, what is probably that man 1 and man 2 are assigned in the same group? So I'm going to come up here. They're in the same group. They're in the same group. So what is the probability that they are in the same group? Because I would be doing probability they're in group A plus probability they're in group D, which is 1/6 plus 1/6. And I now get credit for 2, but not credit for part 1. Does that make sense? So I am showing you a problem where I think most people would just stare at this piece of paper. And I want you to be okay with the fact that I am so lost, make it up and keep going. Because I need you to have a chance to get some credit. And the kid who came and talked to me this is the year of this, I said, well, you could have done that one. He goes, I was so lost I didn't know where to go. I was like, then make something up and use it. You can keep going later and it does something else for the chip method. And then now it says you're deciding which one is better. If you need to decide which one is better, do I want to do 1/6 again? So at least do something different. It again asks you, so I'm getting credit for that again. You understand what I want you to get out of this? I will show you though how to actually do this problem. And once you get started, it's really easy. The order it said was man 1, then man 2, then woman 1, then woman 2. Tails sent them to the treatment group. So what is my first event that I'm going? Who am I dealing with first? All right, what are my options for man 1? And what's the probability of each one of those? Decimal fraction doesn't matter. All right, now who do I go to next? If the first one was treatment, can the second one be treatment?
Yes.
Can the second one be control?
Yes.
All right, then I go on to woman 1. If the first 2 men got treatment, what happens now? She gets control regardless. If it's here, does it matter if she flips? If it's this path, does it matter if she flips? Yes, because there's one of each left. If it's here, there's one of each left. If it's there, she's already in the same group. I could put a C there and put 1, but I don't need to do that. Woman 2 is always going to go in whatever's left. It doesn't matter what she does. What's the probability of my first path? What's probably my next path? And then now I just match these up with, so 1/4 was man 1 and man 2 in treatment. Man 1 and man 2 in treatment. That probability was 1/4. Man 1 in treatment, or I can look at this. My control was man 2, woman 1. Man 2, woman 1. That was 1/8, and then it's easier when you have it on the same paper. But do you see how then I would just go and associate these? So it ends up being 1/4. My other 1/4 is both of the men in control. This is D, and all the other ones are 1A. Method B says there are chips that are marked. There's 2 that are treatment and 2 that are control. Each person selects 1 chip at a time without replacement. What are my probabilities now? What's the difference with the way I think through this one versus the way I think through this one?
It doesn't make sense.
What did I have to think through when I got here? If it was already full, it didn't matter. Is that going to happen with this? No, because there's the exact correct amount in there, so I don't have to think through that part. So what are these actually going to be now? They're all the same. They're 1/6 here. So that eventually it asks about C, and it says, which method should we choose? Well, should we choose the one where they're all the same or they're different? Where they're all the same, so that the likelihood is the same. It gets more into that question, but I want you to get the pieces out of this that you should, to see the setup, to see that it's equations, questions, tables. I've talked to some people about this, about the fact where if they give you a whole page and you think that it's supposed to be a 4-step, it probably is. You shouldn't really base your decision on that, but it could kind of make you feel better. You should be able to go through and pick out what type of problem it is. And I like the idea of doing the ones you feel most comfortable about first. Do about 2 or 3 of them. Skip, read 6, see if you can get started, and finish with the ones you feel least comfortable about. That is just a suggestion.